Here's an example where we can use u substitution. I want to evaluate the integral of t to the third divided by the square root of t squared plus 1 dt. Okay, so one thing I could do is I could choose u to be the portion under the square root here. So t squared plus 1. If I do that and differentiate each side, then du is 2t dt, and then I can divide both sides by 2, so 1/2 du is t dt. Then my integral, I'm just going to point out, I can write it as t squared over the square root of t squared plus 1 times t dt. So I've really taken the t to the third and put t squared here and 1t over here. The point being that the t dt will turn into the du. Okay. Now I know what to do with t squared plus 1, but I don't know quite what to do with t squared. However, if we know that u is t squared plus 1, then we can subtract 1 from each side and figure out that t squared is u minus 1. So this integral, the top of the fraction, t squared, becomes u minus 1. The bottom of the fraction becomes the square root of u, and the t dt becomes 1/2 du. Now I need to rewrite this so I can find an antiderivative. So I'm going to put the 1/2 out front. U over the square root of u is u to the 1/2 power. And then this is a minus sign. 1 over the square root u is u to the negative 1/2 power. Now we're ready to find an antiderivative. So I have 1/2. Antiderivative for u to the 1/2 is u to the 3/2 multiplied by 2/3. Antiderivative for u to the negative 1/2 is u to the positive 1/2 multiplied by 2. Because it's an indefinite integral, we're putting plus c at the end. Just to clean it up, I'm going to distribute the 1/2. So we have 1/3 u to the 3/2 minus u to the 1/2 plus c. However, we're not quite finished because my original problem had t's and I currently have u's. So now I need to replace each u by t squared plus 1 that I chose at the very beginning. So we have 1/3 times t squared plus 1 to the 3/2 minus t squared plus 1 to the 1/2 plus c. And this is my final answer. Now, I do want to point out that there is another perfectly valid way you can approach this problem. At the very beginning here, I chose u equals t squared plus 1. What if, instead of doing that, I made a different choice and I chose u to be the entire bottom of this fraction? So I could choose u to be the square root of t squared plus 1. Okay, in other words, u is going to be t squared plus 1 to the 1/2 power, and I'm writing it like this because I now need to take the derivative. So du is 1/2 times t squared plus 1 to the negative 1/2, and then from the chain rule, I multiply by the derivative of t squared plus 1, which is 2t, and dt. Okay, these 2's cancel out, so I end up with t divided by the square root of t squared plus 1 dt, and that's du. Okay, I will still need to replace a t squared, just like on the other version of this problem. So squaring both sides, we figure out u squared is t squared plus 1. So u squared minus 1 can replace t squared. So now my integral, I can write it as t squared times t over the square root of t squared plus 1 dt. I can replace t squared by u squared minus 1. And I can replace t over square root t squared plus 1 dt by du. Now I can find the antiderivative. We get 1/3 u to the third minus u plus c. And we replace u by this expression, square root of t squared plus 1, or t squared plus 1 to the 1/2, whichever you prefer. So I get 1/3 times t squared plus 1 to the 3/2 minus t squared plus 1 to the 1/2 plus c. And this is our answer. Of course it is the same as what we got the other way. Now, I'm not suggesting that you should ever work out a problem in two different ways unless you're just curious whether or not it works. I'm only doing it two different ways here because I want to point out that there are different ways you can tackle a problem and solve it, and both ways could be correct.